RHS Pre-Calculus presents
Trigonometric functions demystified.
Hello and welcome to the magic of trigonometry. You may wonder, what exactly is a trig function? You've come to the right place to find out.
A trigonometric function is used to relate the angles of a triangle to the lengths of the sides of a triangle. They have a wide range of uses, including computing unknown lengths and angles in right triangles. And they can be used for navigation, engineering, and physics.
There are three different types of trig functions: sine, cosine, and tangent.
If we examine a right triangle with angle theta, we can see that the sine of theta is equal to the length of the opposite side over the length of the hypotenuse. The cosine of theta is equal to the length of the adjacent side over the length of the hypotenuse. And the tangent of theta is equal to the length of the opposite side over the length of the adjacent side.
In a coordinate plane, we can use the point xy to form a triangle. In this case, the sine of theta is equal to y over h. The cosine of theta is equal to x over h, and the tangent of theta is equal to y over x.
For example, let's look at a right triangle created by the point 4, 3. In this situation, the hypotenuse will be equal to 5, which can be found by using the Pythagorean theorem.
As you can see, the sine of theta equals 3 over 5, the cosine of theta equals 4 over 5, and the tangent of the theta is 3 over 4.
See, trig functions just represent side ratios in a right triangle.
There are three additional trig functions that define the inverses of the three original trig functions.
The inverse of sine is cosecant, or the hypotenuse over the opposite side. The inverse of cosine is secant, or the hypotenuse over the adjacent side. The inverse of tangent is cotangent, or the adjacent side over the opposite side.
If we examine inverse trig functions in the coordinate plane, this means the cosecant of theta would be equal to h over y. The secant of theta would be equal to h over x, and the cotangent of theta would be equal to x over y.
Let's refer back to our first example of the triangle created by the point 4, 3. The cosecant would be equal to 5 over 3. The secant would be equal to 5 over 4, and the cotangent would be equal to 4 over 3.
We can also use trig functions to find the missing side lengths or angle measurements in a right triangle. Take this triangle, for example. We know that the adjacent side is 8, and we want to solve for the opposite side, or a. We can set up a trigonometric equation. Tangent of 70 degrees is equal to a over 8. Then we solve for a, and we plug in 8 tangent of 70 degrees into our calculator to get 21.98.
See, trig functions are a great way to show the relationship between the sides and angles of right triangles.
Now that you know the important basics of trig functions, you can solve a variety of different trig problems.
Thanks for watching. How long was that?